Swayam Prabha. Digital India. Educated India.
Discussing the module 7 of Organic Chemical Technology course, and today we will be discussing about the propylene, propylene oxide, propylene glycol, isopropanol and acrylonitrile and some other derivatives. Although acrylonitrile again I will be discussing in detail while discussing the acrylic fiber and its monomer, but some just brief account of this acrylonitrile I will be discussing. This will be the coverage of the lecture, introduction, product profile of the propylene, sources of propylene, emerging technology for the propylene manufacture, commercial propylene technologies, propylene oxide, propylene glycol and polyols, isopropanol, acrylonitrile. So, this will be the coverage in very brief. Acrylic acid also we will discuss. Propylene. Propylene is often referred as the crown prince of petrochemical and is superficially similar to ethylene, but there are many differences both in the production and uses. You see the propylene that has become one of the very important product for the automobile sector, where we are using the propylene there, and so the importance of the propylene that is increasing with the increase in the population, increase in the automobile. So, propylene is used in many of the world's largest and fastest growing synthetic materials and thermoplastics. One of the, as I told you, the propylene to polypropylene, that is one of the major outlet where the major portion of the propylene that we are using. The demand of propylene has increased rapidly during the last 20 years and is primarily driven by the polypropylene demand, because it is not confined to the only the automobile sector. We are also making the in the synthetic fiber, as well as a huge amount of the polypropylene is also that is going to in the hospital for making the syringe and other disposable material, which has replaced practically all the glass waste which we are using there in case of the hospitals. Refinery grade propylene is consumed mainly for the production of cumene and the isopropyl alcohol. This is one of the major outlet, because cumene, that is the raw material for phenol, and so during the process also acetone, that is a byproduct that we are getting, because the conventional process of the phenol manufacture that has been replaced because of the availability of the propylene from the refinery. Isopropyl alcohol, if you see the history of the petrochemical, this was the first petrochemical made from the refinery during the initial stage when the propylene that was actually discovered in the FCC gases, and so that propylene that was recovered and that propylene that was used for the isop. So, sometimes it is called the first petrochemical also. Chemical grade propylene mostly goes into the oxo-alcohols, propylene oxide and acrylonitrile. Another important outlet for the this propylene has been in the manufacture of acrylonitrile, because the conventional process using the acetylene that has been replaced with the propylene using propylene and ammonia process. So, that is one of the another development that has taken place, and now you are seeing the acrylic fiber, which is very important part of the synthetic fiber industry, and completely it has actually the, if you see the changes in the wool industry, because this is the acrylic fiber which we are using. These are the various uses of the, so broad products which we are getting from the propylene, that is polymer, So, polypropylene, polyacrylamide, nylon 66 acrylic acid, where we are using the propylene, propylene oxide. This is having the lot of the other uses, polyether, polyols, glycol ethers, isopropyl amines. Similarly, the propylene glycol unsaturated polyester resin, where the use of the propylene glycol is there, and here in the during the manufacture of the propylene glycol, both MPG, DPG and TPG, mono, di and tri propylene glycol that is made. It is just similar to the ethylene glycol manufacture which we are having in case of the ethylene. From the ethylene derivatives already we discussed about the product profile of the and the how the MEG, DG and how we are controlling them. Another important which I told you that is the acrylonitrile, because acrylonitrile, that is one of the major acrylic fiber that we are making, and then the acrylic acid that we are making from the, and that acrylic acid that is going for the acrylate, methyl acrylates and adiponitrile, where the lot of the uses. Isopropanol, that is another very important product from the propylene, which is for the acetone, cosmetic, solvent, pharmaceutical industry and the isopropyl acetate. Miscellaneous chemical also we are having from the propylene. So, this is the, you can just see the, this is the chemical utilization. One of the major utilization I told you, that is in the automobile sector, where the propylene in the form of the polypropylene that is going, this part, that is the major actually the your uses of the the propylene is there. These are the, let us discuss about the slightly more, that the chemicals. These are the some of the chemicals: 1 butanol, 2 ethyl hexanol, allyl chloride, epichlorohydrin, polymer, polypropylene, polyacrylamide, nylon 66, acrylic acid that we are making, propylene oxide, polyether polyols, glycol ethers, polyols that we are using in case of the polyurethane, isopropyl amines, propylene carbamide and surfactant industry, that is the propylene glycol, all the 3 glycols, so unsaturated polyester resins, food additives, cellophane, paints and coating, plasticizer, functional fluid, antifreeze and tobacco treatment that we are using. Acrylonitrile, as I told you, this is acrylic fiber, acrylic acid, acrylates, methaacrylate, adiponitrile which is going for the manufacture of nylon 66, isopropanol, acetone, cosmetics, solvents, polyols, that is the polyurethane I told you, and the polyester. What are the, let us discuss the, what are the sources of the propylene. As I told you, the first major source of the propylene before coming of the petrochemicals, that was the FCC. So, the steam crackers, now it has become the major source of the propylene. Catalytic cracking means they, now what we are doing in the case of the steam cracker also, the now the catalyst is available where you can do the catalytic cracking of the naphtha instead of only the steam cracking, so that the more selective production of the or the just equal 1:1 proportion of the propylene that may be there. Propylene from the FCC light, and that is one of the very important source in case of the FCC, and most of the refinery they are recovering this propylene from the FCC, and some of the refinery like Jamnagar, the propylene from the FCC, that is one of the very important product there. Another actually the development that is there in case of the on purpose propylene, that has been the as per the requirements of propane dehydrogenation. As in case of the ethylene, it may be ethylene, ethane dehydrogenation for ethylene. Similarly, here we can go for the dehydrogenation of propane, and you can produce propylene, because the propane is available from the natural gas, from the LPG. So, this is the how the propane that can be utilized for the production of the propylene. Another source is the metathesis, that is also one of the important development in case of the propylene manufacture. Then the last methanol to olefin technology, that has come in a big way, and lot of the research that has been done on this technology, and now that has been commercialized also in some of the country, and because of the availability of the natural gas, and especially with the coming of the shale gas, or in the future it may be the gas sided lot of the natural gas that will be available, that can be converted to methanol, and methanol to olefin, means mostly it is the propylene technology, sometimes methanol to propylene, or sometimes it is also called the methanol to plastic technology, means the from the propylene again we are going for the polypropylene. Improved FCC technology, as I tell you, the initially the technology which was available, the catalyst which was available in case of the FCC, the yield of the propylene that was low. So, improved FCC technology can effectively maximize the propylene yield from the traditional FCC feedstock and selected naphtha, while FCC operates typically produce less than 6%. That was the in the initial stages when the FCC that was being operated more in the gasoline mode than the propylene, because it was only after the major usage when the increase when the usage of the propylene that was increased. Now they refine, they have just started to operate the FCC in the both the gasoline and the propylene mode depending upon the requirement. So, a specialized fluidized bed catalytic process can further raise propylene yield as high as 20% or even higher. One of the development that has been in case of the, because normally if you are increasing the CVLT, you can go for the more propylene yield, because only the choice, your choice has to be there whether you want to operate your FCC on the gasoline mode or the propylene mode. So, the deep in this area, the development in case of the FCC to meet the demand of the propylene, that is the deep catalytic cracking, which is the commercially proven fluid cracking process to selectively crack a wide variety of the hydrocarbon feedstock into light olefins, particularly the propylene and isobutylene. Other specialized, already we discussed about the recovery of the C4, C5 gases from FCC and the cracker. So, the propylene and isobutylene, these are the two very important product of the refinery, that may be the isobutylene, as I told you. Earlier we started making the MTB and MTB that has been made, but still isobutylene that can be a major raw material for the synthetic rubber industry. Other specialized technology are also there which produces higher propylene apart from this deep catalytic cracking. These are the some of the development that has taken place in case of the FCC, that is the deep catalytic cracking. Other I told you the catalytic pyrolysis, high CVLT FCC, INMOX technology that has been developed by Indian Oil Corporation, Maxofin that is the petro FCC, select component. So, if you see the propylene yield in these processes, that is quite high, around 40 to you can say the 25% in some of the cases. Select component cracking means the catalyst will be such that the production of the, it will be more selective towards the propylene. The yields of the conventional versus high propylene FCC, this is the again one figure I am giving the composition of the gases which are getting. Here you see the butenes gasoline yield, because you will have when you are operating FCC in the propylene mode, definitely that is on the cost of the gasoline. So, as I told you, the depending upon the situation, depending upon the requirement, you can operate the FCC either on the gasoline mode or the propylene mode, because the propylene is more value added product than the gasoline. So, this is the you see the percentage of the FCC and your propylene, that may be there. In case of this 12 to 25% propylene, that may be there. Butenes will be also in the appreciable quantity. Gasoline yield, that will go down 47 to 53, here it is only 30 to 40%. This is the composition of a typical FCC gas operating in the gasoline mode. Here you see the propylene is 21%, propane is also there, that you can separate, and then the propane that can be used for the dehydrogenation of the propane to propylene. These are the some of the commercial propylene technology: EOP hydro MTO process, propylene process, EOP olefix process, superflex process, olefin conversion technology. This process involves production of propylene from ethylene and two butenes, which I was telling, that the that is in case of the metathesis also that we are doing. The ethylene and two butenes in a fixed bed metathesis reactor, that is the process called commonly the metathesis reactor, containing proprietary catalyst which promotes reaction of ethylene and two butene to form propylene, and simultaneously isomerizes one butene to two butene. So, that will be again available. So, the licensor is ABS Limus Global. EOP olefix process. This process produces polymer grade propylene from propane, and the process consists of a reactor, catalyst regeneration section, and the product separation, and the final fractionation of the product, so that to separate the propylene. The process uses a platinum catalyst, and this is the catalyst, the commercial name of the catalyst. These are all the proprietary catalysts that is being used in all the process. EOP hydro MTO process. This process converts crude methanol produced from the synthesis gas using natural gas to ethylene and propylene, and can be operated either a maximum ethylene or a maximum propylene production mode using MTO 100 silico aluminophosphate synthetic molecular sieve based catalyst. Again, this is the proprietary catalyst. The process utilizes fluidized bed reactor and regenerator. So, this is the EOP hydro methanol to olefin process. So, the choice is that depends upon the whether we are interested in ethylene and the propylene. So, that can be operated in the both the mode, or it may be 1:1. Then C4 hydrogenation, already I discussed. This process involves the production of polymer grade propylene plus an isobutylene rich steam RMTB by upgrading the low C4 steam pyrolysis C4 cuts or butene rich cut. This already I discussed. Olefin ultra CM, a new ultra high activity JCM 5 additive that provides the highest activity, has been developed by Division Catalyst Division, because this is one of the largest catalyst manufacturing unit in the world. Continuous development that is going on, the various catalysts, whether it may be the reformer catalyst, whether the FCC catalyst, or for the increasing yield of the propylene. This is the KVR's Maxofin process. Again, this is the KVR is one of the another leading licensor of the petroleum and petrochemical processes. This process is based on fluidized bed cracking of gas oil and residue feeds using JDSM catalyst and proprietary Maxofin 3 catalyst additive. The process gives 50% higher propylene yield from gas oil. Here you see the instead of the other raw material we are using the gas oil. So, the definitely the advantage in case of the that the gas oil feedstock is there, and so the 50% higher propylene yield will be there. Catalytic dehydrogenation of the paraffins. This is one of the what we call the on purpose propylene. So, catalytic dehydrogenation of light paraffin is of increasing importance because of the growing demand of the olefins such as propylene and isobutene and N-butenes. The propane dehydrogenation accounts for 2% of the total world propylene production. This is the same catalytic dehydrogenation takes place, the condition for the dehydrogenation of the paraffin. The catalytic dehydrogenation takes place at high temperature using platinum base or the chromium alumina or the Fe chromium alumina as catalyst. So, various combination that is there. Then already I discussed about the methanol to olefin technology, the DOP process. The process produces propylene from natural gas via methanol by converting methanol to dimethyl. This is another process development, that the methanol to dimethyl ether, because dimethyl ether as such it can be used in the fuel stream. So, the lot of the interest now there is for the manufacture of dimethyl ether, and dimethyl ether is converted to again into propylene in this process. So, this is the technology, process technology that is available. This is the process methanol to olefin technology, where methanol and dimethyl ether pre-reactor and different reactors are there. From the different reactors, the products which you will be getting, that will go to fractionating column, which I told you, the fractionation of the product, and then the purification section, and this is the gasoline, propylene, LPG. So, this is the final product from this you are getting during the from the methanol to olefin technology. So, here the raw material methanol, actually if you see, as I told you, the methanol will be from the synthesis gas, and the raw material that may be the, because why the interest in methanol is because of the coming of the huge amount of the natural gas that is available in the various country. At the same time, there is no interest also for the gasification of the coal. So, coal to, this is the reason why the China they have gone, because their coal quality is good. So, methanol to polypropylene, that is they call it the methanol to plastic technology, means the olefin, and that olefin that will go for the making of the polypropylene. These are the some of the commercial catalytic dehydrogenation of the paraffins: Olefex, Catafine, FBD4 and Stahl Phillips process. So, these are the major dehydrogenation of the paraffins, because here directly the paraffins propane that we are getting from the, because in refinery also we are making the LPG, the propane that can be separated, and that propane that can be utilized, or the propane or the butane that can be utilized for the, there it may be the butylene, here it is the propylene. So, this is the reason why the importance of the catalytic dehydrogenation is there, and more units are coming, because the on purpose propylene which we are producing without going for the catalytic naphtha cracking or the cracking process, you can produce the propylene. Methanol to olefin technology, which I discussed earlier, this process produces propylene from natural gas via methanol by converting methanol to dimethyl ether in adiabatic reactor using high activity, high selectivity catalyst. The methanol water dimethyl ether stream is then fed to the series of methyl the methanol to propylene reactor, which I show you in that diagram, that the series of reactors are there. If you see the, these are the series of the reactors where the conversion is taking place, and finally it is going for the separation. So, the finally the product stream is first process for removal of the trace of water, CO2 and DME, followed by further processing for yielding the polymer grade propylene. Metathesis, already we discussed about the ethylene and butane can be processed in the metathesis unit to produce the additional propylene, and C4 to C8 can be converted to light olefins through interconversion process to light olefins or by recycling these hydrocarbons to FCC. This is the flow diagram for metathesis reactor, that is the ethylene and 2-butene that will go into the metathesis reactor, and the regenerator, and the finally this is the propylene column. This is the ethylene column where the ethylene fraction that will be C2 fraction that will be separated, and that will, because this will be the more heavier, so this will go to the another column where the propylene that will be separated with the C4 and C5 phase. So this is the process in case of the metathesis that we are using. Now let us, this was all about the various routes for getting the propylene, because you see the propylene, as I told you, that was called the crown prince means, but now it has got the equal importance when you compare with the ethylene. So now the lot of the interest there has been. So these are the technology which I developed now that is available. Some of the technology they are being operated also. Already some of the plants they have gone for the modification of the catalyst also. They are operating the FCC and the propylene mode also, so that the more and more propylene is available for the. So these are the three major products: propylene oxide, propylene glycols and polyols, which we are making from the other usage, are also the other products are also there. But this is one of the, just like in case of the ethylene, it was the ethylene oxide, ethylene glycol, so and alcohols of polyols. This is the important from the polyurethane point of view. And so this is the propylene oxide, propylene glycols and polyols are the important derivatives of propylene. Propylene oxide is used for the manufacture of propylene glycol and polyols, because the starting material here the same from the propylene to propylene oxide, the process we are using just similar to the ethylene oxide process. Major consumption of the polyethylene, the propylene oxide is manufacture of polyurethane, the polyester resin. Propylene glycol, which I told you that we are making from the propylene oxide. So the propylene glycol find major application in the manufacture of unsaturated polyester resin, food additives, pharmaceutical, personal care, tobacco humectant, cellophane, paints and coating. Another important product which I was telling, polyols, major use is the manufacture of the polyurethane. Propylene oxides, there are two major processes for the manufacture of propylene oxide. One is the propylene chlorohydrin process, another just like it is the chlorine chlorohydrin process that was in case of ethylene oxide. Here also the same process, same way. The problem is the same, remaining same, that is the chlorine handling is there, corrosion problem is there. So with the development of the propylene oxide, now the most of the propylene oxide that is being made through this process, the propylene oxide, and also it has enhanced the actually the production, because the more and more propylene that is available from the refinery and the cracker plant. So this was, let us discuss, although this is the only the old method, the propylene chlorohydrin route, this is not being used, but this process was the starting process. So I thought to discuss this process. So the chlorohydrin process consists of formation of propylene chlorohydrin by the reaction between the hypochlorous and the propylene. The propylene chlorohydrin is exposed to propylene oxide by a 10% solution of milk of lime or NaOH. The process steps in the propylene chlorohydrin process is propylene hypochlorination, neutralization, dehydrochlorination, and then the purification. These are the major steps involved in the chlorohydrin process. This is the reaction that is taking place in case of the chlorohydrin process. Again here the same problem of the generation of the calcium chloride, RNaCl is there. So, and the involvement of the HCl is also there. So, the chlorine and HCl, so the highly corrosive atmosphere, and because of that reason now this process has been replaced with the propylene oxidation route. So, let us discuss now the propylene oxidation route. So, propylene in this process, propylene and peracetic acid in ethyl acetate, which is produced by oxidation of acetaldehyde, are reacted in a. So, this is the peracetic acid from the acetaldehyde route I discussed while discussing is that peracetic acid also one of the product that we are getting from the acetaldehyde, that they are reacted in a series of 3 specially designed reactor at 50 to 80 degrees centigrade and 90 to 120 megapascal pressure. This is the reaction that is taking place in case of the propylene, and the reaction you see this is the propylene oxide that we are getting, and this is the byproduct that we are getting here, that is the acetic acid in the during the manufacture of the propylene oxide. The reaction products from the reactor in case of the propylene oxidation is fed to the steeper, where a mixture of propylene and propylene oxide are obtained as top product, while mixture with ethyl acetate and acetic acid is obtained as bottom product. Both mixture are then fed to the two separate columns, where separation of the propylene oxide, ethyl acetate, acetic acid and heavy ends takes place. So, this is the process which we are using for the manufacture of the propylene oxide from the propylene route. Let us discuss now the another important product from the propylene, that is the propylene glycol. Propylene glycol means all the 3 propylene glycol, monopropylene glycol and dipropylene glycol, the propylene glycol, because all the 3 glycols that will form again as the same as it is being done in case of the MAG. You will have to control the amount of the water in the hydrolysis. So, propylene glycol is made by hydrolysis of the propylene oxide. The process steps involve the hydrolysis of the propylene oxide resulting in a formation of monopropylene glycol, a small amount of dipropylene glycol and tripropylene glycol. So, after the reaction, as in case of the, if you remember the flow diagram of the MEG, same the concentration section, concentration of the glycol solution in multiple effect evaporator, and after this that is going to the separation distillation section, where the separation of the MPG, DPG, monopropylene glycol, dipropylene glycol and tripropylene glycol is separated because of the difference in the boiling point from the MPG column. A series of distillation column where MPG is separated in the first column because it is lighter, and so even the amount of the, as I told you, the amount of the DPG and TPG that can be adjusted during the hydrolysis process, taking the your amount of the propylene to water ratio. So, that was about the glycols. Another important product which we are getting from the propylene, that is the isopropanol. As I told you, the isopropanol, that was the first product petrochemical, because the propylene that was available from the refinery. So, ever since its first commercial introduction in 1920 as one of the first petrochemicals, isopropyl alcohol has found wide use as a solvent, raw material for other chemical products like acetone, isopropyl acetate, glycerol, isopropyl and diisopropyl amines, corrosion inhibitor, diisopropyl ammonium nitrate, flotation agent, isopropyl hexanate, isopropyl myristates. So, these are some of the broad range of the product that we are getting from the isopropanol. These are the two major technology that is available for the production of the isopropanol, the esterification of the propylene by sulfuric acid and hydrolysis. These are the reaction that is taking place after the treatment, esterification and the hydrolysis part, and we are getting the isopropanol. Direct catalytic hydration of the propylene. So, this is because when you are handling the esters, so definitely the problem of corrosion and other problems are there. So, this process that is more it is better than the this process by sulfuric acid and hydrolysis route. Let us now, actually this was the some of the major products. Another major product I will be discussing only the brief summary of this acrylonitrile, because we are discussing the propylene part, but in detail of the process we will be discussing again while discussing the acrylic fiber in the module 8. There the what are the various monomers that is required for the synthetic fiber industry, that will be discussed in more detail. So, the acrylonitrile was here also, if you see the historical background of acrylonitrile and a large number of the chemicals, that was the actually the alternative route, means the acetylene route. So, acrylonitrile was first synthesized by Murray in 1893, but remained practically a laboratory curiosity until the development of the acrylonitrile and butadiene used as a self-sealing lining the aircraft gasoline tank during the World War II. This was the actually the development of the nitrile rubber that was there, acrylonitrile butadiene rubber, that was being used as the sealant, because that was having the resistance to the. So, that was the requirement at that time for the aircraft, and so that led to the development of the acrylonitrile also, or the commercialization of the acrylonitrile process. But later on, the more and more it was for the use of the acrylonitrile for making of the acrylic fiber. So, this, as I told you, with the development, the moderate tonnage application, its major application started with the production of the acrylic fiber and modified acrylic fiber, which I told you, because this was the change in the even the production pattern also, and the resin acrylonitrile, ABS resin and styrene acrylonitrile resin. So, styrene combination and the butadiene combination. So, different resins we are, that is coming in the specialty grade of the your polymer. So, that has led to the further development in case of the requirement of the acrylonitrile, where large tonnage of the acrylonitrile being used. Worldwide demand of the acrylonitrile was approximately 5 million tons. Demand in the Asian market reached 50% of the worldwide demand, and high rate of the growth is expected to continue. But one of the major development that has been in case of the acrylonitrile, that was the development of the process by amino oxidation of the propylene. Let us first discuss some of the routes again, because just I will give the brief outline of the process, and then as I told you, we will be discussing more in the module 8 about the acrylonitrile. So, acetylene route was the first route which was available, because this was the the petroleum route, that was the formation of the acrylonitrile from the acetylene. Another route that is available, that is the ethylene oxide route, that is from the ethylene oxide we are making the acrylonitrile. acetaldehyde route, propylene route is also, but this is the one of the major breakthrough that has been the process of the acrylonitrile by amino oxidation process. So, acrylonitrile by amino oxidation of the propylene, a typical acrylonitrile plant consists of the acrylonitrile reactor section, acrylonitrile recovery section, acrylonitrile purification section and the HCN purification section, because here in the process we are getting acetonitrile also one of the important your this byproduct. Propylene, ammonia and air are fed to the fluidized bed catalytic reactor with ammono oxidation of the propylene that is taking place. So, again as I told you, the flow diagram and other details will be discussing while discussing the acrylic fiber. So, let us come to the another important outlet for the propylene is the polyols, where the, because this is finding wide application in the manufacture of the polyurethane. So, polyols are made by polymerization of the propylene oxide, ethylene oxide using a proprietary catalyst chain starter. The process consists of the raw material preparation section, reaction section, the purification section. So, raw material preparation section, preparation of the of chain starter and addition in the reactor along with the ethylene oxide and the PO. The retention time, polymerization using catalyzed chain extender, and then the purification involves the purification of the raw polyol by neutralization. Another important outlet for the propylene that has been the acrylic acid, which is used for the acrylate that we are making from the acrylic acid. So, that is one of the very important your product of the propylene. The acrylic acid is a versatile chemical which find application in the manufacture of glacial acrylic acid and acrylic esters, acrylates and the methaacrylates. Polyacrylic acid, which is used in the manufacture of super absorbent polymers, flocculants, detergent, paper chemicals and resin. Various acrylic esters are methyl acetylene, ethyl acrylate, butyl acrylate, 2-ethyl hexyl acrylate. So, this is the about the acrylic acid. These are the various process technology that is available for the acrylic acid: ethylene route, ethylene oxide route, ethylene route and the chlorination of the propionic acid, propylene route, formaldehyde and acetic acid route. So, this was about the propylene and its derivatives. Apart from this, some of the other propylene derivatives are also there. So, propylene, one of the major, because the development that has taken place in the refinery and the petrochemical complexes is the catalyst development to enhance the production of the propylene either from the FCC or from the when the catalytic cracking, which the process we call advanced catalytic cracking process that is there, which is where the more propylene yield will be there. So, that part we discussed earlier also. So, this is the how the propylene production and the various product of the propylene, their importance we have discussed. In the next lecture, that will be on the aromatic production and the aromatics, various aromatics, because the aromatics are also playing very important role in the chemical, organic chemical industry, either you can say in the pharmaceutical industry, it may be pesticide, it may be explosive, it may be the your dyes and intermediate. So, we will be discussing in 2 lectures, one is the aromatic production and second will be on the various aromatic products which we are making.